All right, you might want to pause here to make sure that you got all that down because I'm going to start a new page, which means I'm going to erase everything here. All right, so now we're going to talk about the distributive property. Now, if you remember the distributive property, you can probably give your own real-life example of distributive property, but I'm going to just write it as an equation. All right, the distributive property says that if you have a term on the outside, and then parentheses and two terms on the inside either added or subtracted, so it can be a sum or a difference, then you distribute that term on the outside to each term on the inside through multiplication, okay? So A times the quantity B plus C is equal to A times B plus A times C, or minus if you have a difference, okay? So let's solve distributive property by justifying each step. Okay, so our equation is -5 times the quantity 7W plus 8 equals 30. And we're going to, again, follow through all the steps and give reasons. So our first reason, every time you start a proof, is that whatever you have is given. So this is the given equation, okay? So now what we're going to do is we're going to use distributive property to rewrite this equation by distributing that -5. So I got -35W minus 40 equals 30. And the reason for this one is, what did we do? We used distributive property. And again, I'm abbreviating property to prop because I just don't want to write the whole entire thing. Okay, so we want to get W alone. What should we do in order to solve this equation? Add 40 to both sides. Let's do that. So plus 40 plus 40. And what is the reason for adding 40 to both sides? This is the addition property. Add prop of equality, which says that if I add the same thing to both sides of an equation, I get the same answer. So I'm going to rewrite it as -35W equals 30. Oh no, I messed up my colors. It's fine. And I do this because I simplified, or I combined like terms. Oh, Miss Miller forgot to actually add the 30 to the 40, didn't she? 70. All right, last step. We're going to divide both sides by 35. And this is the division property of equality. Last but certainly not least, we're going to simplify. We get W is equal to -2, and that is because I simplified, and we are done. Boom. Okay. I'm going to put a problem for you to try on the side. Again, you can abbreviate whatever your reasons are, but please make sure that you give the reasons. It's really important that you know what each of the reasons are for each of the problems. So here's your try it. It's 3 times the quantity 3x plus 14 equals -3. Take a minute, pause this video, do that with the reasons, okay? Again, you can abbreviate your reasons, do whatever you want, but don't just solve it, write down the reasons. Okay, hopefully you did that. The next section we're going to talk about is reasons or other properties of equality that you might be using in the practice work and how you can use that sort of stuff. So let's make ourselves a little bit of space. I'm going to use a black pen again. There are 3 properties that we're going to talk about. Okay, so these 3 properties are the reflexive property, the symmetric property, and the transitive property. My favorite is the transitive property. I think the reflexive and symmetric property are silly, but useful. Like you use all of these properties all the time, but now they have names. So the reflexive property says that something equals itself. So if you have a side length, it equals the same side length. So let's say we have side length or let's say we have side length AB, it is equal to side length AB, okay? So that's what it says. It is the same thing. Something equals itself. This symmetric, the reason why we use reflexive property is when we're making proofs about things that share a side length or share an angle or whatever. The symmetric property says that if A equals B, then you can flip it around and say B equals A. Or if you said side length AB equals side length BC, then you would know that side length BC equals side length AB. Okay, and the reason for this is just because sometimes the proof wants you to have something written out one way versus another way, or sometimes it's just easier to look at it one way or another way. Okay, so symmetric means that you can flip it around. The transitive property is a little bit different. It's kind of like the law of syllogism or syllogism. I don't know how to pronounce it. But it says that if something is equal to something else and that something else is equal to a third thing, then the original is equal to the third thing. So like if angle A equals angle B, if angle A equals angle C and angle C equals angle B, then angle A also equals angle B, which makes a lot of sense. Okay. Different reasons for each of those different properties of equality, but it is really important that you know all three of them. So go ahead and take a minute, pause the video, make sure that you get all three of those properties of equality written into your math notebook. And then I'm going to start a new page. So pause. Okay, so really quick, in the left-hand side, I'm going to do what I call notation station. And the notation is really super important this time. If I say that angle A equals angle, or is congruent to angle B, that means that, like, I know that they're congruent angles. I know that they're not only equal in length, but they're like the same thing, okay? To prove something's congruent, you have to prove that it's equal in length, but we'll get to that eventually. But if I want to say that the measure of angle A is equal to the measure of angle B, I write it like this. So when I use this little m, it means that I'm using angle measures. Okay. It also applies to when I have side lengths. So if I said the measure of AB is equal to the measure of BC, then I'm using lengths. Okay. If there's no measure, I'm just talking about the angle. I don't care about the measure. I don't care about how many degrees it is or how long it is. But if I have the little m, I do care about what it measures, what the angle measurement is. Okay, super important. Get that notation station in there. And then we're going to use properties of equality to prove an angle measure. Okay, go ahead and draw this diagram. It gives us some information already. We want to prove that angle DBA, oh, that was a bad D, angle DBA is equal to angle EBC. Okay, so we want to prove that angle DBA is equal to angle EBC. So I'm going to do like a highlight, a little outline. DBA is this angle right here. So it goes from this line DB all the way to this line BA. Okay, it's that angle. And EBC is the opposite. So we're going to start by drawing ourselves two columns. Okay, the first column is statements. This is just like the algebraic reasoning, but now we're calling the equation the statement. And then on the right-hand side is the reasons or the justifications. And the reasons have to be mathematical reasons. Like they're not just because I said so, okay? So we're going to start with something that is given to us. We know for certain is true. Now we know from the diagram that angle 1, measure of angle 1, is equal to the measure of angle 3. And how do we know that? Because it's given in the diagram. The diagram says right here that angle 1 is equal to angle 3. So we're going to write given. Okay. Now, in order to prove that these two angles are the same, we're going to write them in terms of angles 1 and angles 2. So we're going to rewrite angle DBA using the angle addition postulate. Angle DBA equals angles 2 plus angle 3. And this is by the angle addition postulate. Okay. All right. Now, I'm also going to write that angle I'm going to do this. I'm going to write now that angle DBA equals angle 2 plus angle 1. Now, why can I write that? Why can I replace that angle 3 with angle 1? It comes from the given statement. So I'm going to substitute. My reasoning is substitution because I substituted angle 3 for angle 1. So instead of saying angle 2 plus angle 3, I did angle 2 plus angle 1. Why would I do that? Well, because of angle EBC and what angle EBC consists of. So the next statement that I'm going to make is that angle EBC equals angle 2 plus angle 1. And I can say that because EBC is the sum of the angles. So this is the angle addition postulate again. Okay. Now that I've got that angle addition postulate and I have these two statements, I can say because angle DBA equals 2 plus 1 and angle EBC equals 2 plus 1, I can say that angle DBA equals angle EBC. Now this one's weird. The reason I can say that is because of transitive property. Yay. And then we can do that little box.